Airtightness. Airtightness is the control of airflow within a building. This means there is no unexpected air leakage, so there is no warm air escaping or no cold air infiltration. When building a dwelling, we want to make it as airtight as possible. This is highlighted in the image by the red airtightness barrier all around the interior of the building. By making a building this airtight, we will also need a ventilation system, such as an MHRV, mechanical heat recovery ventilation system, or a demand controlled ventilation system to ensure a comfortable living environment. We will look at these ventilation systems in another video. There are several methods to making a dwelling airtight, such as using a layer of plaster on the internal wall with airtightness tape at junctions. An example of this is shown in the image of the sill detail. The inner wall is plastered and there is airtightness tape at the junction of the frame and the inner wall to ensure there is no break in the airtightness barrier. Another example could be using a service cavity and an airtightness membrane. Again, airtightness tape is used at junctions or breaks in the airtightness barrier, and if there is a service, for example a pipe or wire penetrating the airtightness barrier, then a grommet would be used. There are many approaches possible to achieve an airtightness barrier which would meet the different low energy building requirements, but it is more important to understand the concept rather than all the different approaches. In order to eliminate air leakage, there needs to be an unbroken airtightness barrier around the internal of the house. If there is a leak in this airtightness barrier, then there is a path from the inside to the outside and air leakage will occur. This will result in the warm air escaping and cold air infiltrating inside the building. So why go to such effort to make a dwelling so airtight? It is because of the benefits, of which include reduced heat loss, reduced heating bills, improved thermal performance of the structure, improved thermal comfort, so a steady temperature is maintained throughout the building. Next, we are going to look at the requirements of different low energy building construction methods. To gain Passive House certification, a building must reach the standard of less than 0.6 air changes per hour when tested at a pressure of 50 pascals. This simply means that there must be less than 0.6 cubic meters of air change per hour for every square meter of floor area, when the difference in air pressure between the inside and outside is 50 pascals. While if you were to retrofit a house to the inner fit standard, the dwelling would have to achieve less than 1 air change per hour. To meet the NZEB standard, a building must meet a standard of less than 3 air changes per hour. And lastly, if you were to retrofit to the SEAI deep retrofit standard, then the dwelling would have to achieve less than 5 air changes per hour. To get an accurate measurement of the airtightness, a blower door test is used. The blower door fan is usually set up in the doorway of the main entrance of the dwelling. Windows and doors are closed while vents and fans are sealed. The fan is then turned on and tested for overpressurization. The house is subjected to 50 pascals of pressure for 1 hour while the airflow rate is measured. The goal of the first stage is for the dwelling to maintain the excess pressure of 50 pascals. The fan is then turned around and the test is repeated, this time testing for underpressurization. 50 pascals of pressure is pumped out of the house. The results of the test are based on the building's capability to maintain this negative pressure. The average of the two tests are then calculated to determine the airtightness of the building. If the required standard is not met, then a smoke test will need to be carried out to find the areas of air leakage in the house. These air leaks can then be sealed and the blower door test can then be repeated until the required standard is obtained. Thanks for watching.